In writing ratios, what we're doing is essentially throwing numbers into fractions willy-nilly. And the problem with that is that in a fraction, the numerator and denominator are both integers. And furthermore, in a fraction, the denominator cannot be 0. For the moment, we're going to continue to avoid ratios in which the denominator is 0, because they aren't very relevant to the kind of work that we're interested in right now. However, it's very hard to avoid ratios where at least one of the numerator and denominator turns out to contain fractions. To give an extremely simple example of a ratio in which the numerator and denominator contain non-integers, suppose that we have a 12-pack of soda which costs $5.65. The ratio of cost to cans of soda is $5.65 to 12 cans. But this 5.65 over 12 is an example of what's called a complex fraction. A complex fraction is just an expression that looks like a fraction. So it's written in the form a over b, and the denominator is still not 0, but at least one of the numbers is not an integer. So examples of complex fractions might include the 5.65 over 12 that we mentioned a moment ago, something like 12.5 over 100, something like 3 1/3 over 5 1/4, or something like 2 over 1.08. At least one of the numerator or denominator contains a number that is not an integer. When we encounter a complex fraction, we have several options. One option is to just leave it alone and let a calculator deal with it. For example, if we have the complex fraction 3 1/3 over 5 1/4, and we want to multiply that by 26, for example, we could simply enter that complex fraction into the calculator as a division problem, and then multiply the result by 26. We can convert the result to a fraction, or we can convert the result to a mixed number, or we could report the result as a rounded decimal, or as a repeating decimal if we think that we can see the repeating pattern. In many cases, this will be our approach to complex fractions. If we want to manipulate them by hand, however, we'll need to simplify them. Our first option for simplifying a complex fraction is to multiply the numerator and denominator by the same number, usually a whole number, which works well with decimals. For example, if we have 2 over 1.08, we can multiply the numerator and denominator each by 100. Of course, we can get an equivalent by multiplying the numerator and denominator by whatever we like, as long as it's the same thing. Why choose 100? Well, 100 is easy to multiply by. And when we multiply a decimal by a power of 10, that has the effect of moving the decimal point. We chose 100 because that gave us whole numbers in both the numerator and denominator. If we're feeling ambitious in our simplifying, we might notice that 4 is a common factor of both the numerator and the denominator. And so this is equivalent to 50/27. 50 and 27 now have no factors in common. The other way that we might choose to simplify a complex fraction is by understanding the fraction bar as division. So for example, if we have 12.5 over 100, we can understand that as 12.5 divided by 100. If we'd like to work this out by hand, well, we'll need to convert 12.5 to an improper fraction. 2 times 12 is 24, plus 1 is 25. And rewrite the division as multiplication by the reciprocal. And now I see a common factor of 25 here. I get that 12.5 over 100 is equivalent to 1/8. Notice that the calculator could have done both of these simplification steps for us. We could take 2 divided by 1.08 and convert the result to a fraction to get our 50/27ths. Or we could take 12.5 over 100, convert the result to a fraction to get our 1/8. So perhaps a hybrid of these three options would be to use a calculator to simplify the fraction.